There we go. All right, so on today's lecture, we're going to be looking at questions 33 to 40. Now, number 33, it's a little more realistic. This thing's a little more realistic. The funny thing is that similar triangles are very, very important. Similar triangles are for us to be able to measure something without actually bringing up the tape. For example, I want to go measure up a tree, something I cannot climb. I want to measure the height of a building. I want to measure something that's pretty. So I'm just going to come over and I want to go, all right. Number 33. It says a flagpole 4 meters tall casts a 6-meter shadow. So I'm going to create, there's a flagpole. So let me draw, there's the flagpole. It's 4 meters tall. I don't need to be that creative, just a flagpole just going up. And then the shadow, what tends to be on the ground, is 6 meters shadow. At the same time, a nearby building casts a 4-meter shadow. I'm gonna do my measurement here the same. So these are not measured to scale, but there's a building and the shadow of the building happens to be 24 meters. The nice thing is if I connect my sides, I have 2 triangles. All right. Once again, my triangles are not measured to scale. And I have to solve for x, right? I don't know the height of the building, so that's why I call it x. So I'm going to solve for x. The way I'm going to do this, on the triangle where I have x, I see 2 numbers. Now I'm going to make a fraction out of that. So I'm going to say x over 24 is equal to, x is the height of the building. So x goes with 4 because 4 is the height of the flagpole. 24 is the shadow of the building. 24 goes with 6. And I've been saying we can cross multiply whenever we're comfortable. We can simplify if we need to, but we can cross multiply whenever. I'm not going to simplify. I'm just going to cross multiply. Then we have access to calculator. So I'm just going to cross multiply. 6 times x, that gives me 6x. 4 times 24, that gives me 96. Now to solve for x, to get the x by itself, let me divide both sides by 6. So x equals 16. All right, in meters, because that's the measurement that we're using in this case, in meters, that building is 16 meters tall. Nice. Same thing with question number 34. There's a flagpole. There's a flagpole that is 3 meters tall and casts a 4-meter shadow. So I'm gonna say there's the flagpole is 3 meters tall and it has a shadow that is 4 meters. I'm gonna start already. I'm gonna create a triangle. I only know the height and the shadow. At the same time, a nearby building casts a 23-meter shadow. So I'm gonna say there's a building. I'm gonna call X the height because I don't know the height. And the shadow is 23. I'm gonna close those two so it makes a triangle. How tall in meters is the building? Round your answer to the nearest tenth if necessary. All right, kind of like how we did the previous question. The triangle where x is, I see the measurements x and 23. I'm gonna make a fraction out of that. I'm gonna write x over 23 equals, now x is the height of the building, so x goes with 3, which is the height of the flagpole. 23 is the shadow of the building, so 23 goes with 4, which is the shadow of the flagpole. And then I'm just gonna cross multiply. 4 times x gives me 4x. 23 times 3, that's equal to 69. Let me divide both sides by 4. Then I see that x happens to be 17.25. Okay. I got decimals this time, and that will happen. That will happen a lot. I got decimals, 17.25, but I see here, round your answer to the nearest tenth if necessary. So if you have decimals, make sure you only have one decimal place. I do take a look at the second decimal place. My second decimal place is a 5, which is big enough, right? Big enough is 5 or more. When it is big enough, that 5 is going to push the previous number up. So my answer in this case will be 17.3. If you have decimals, make sure you round it to one decimal place. All right, I do take a look at the second decimal place. It was big enough, so push the 2 up to 17.3. If it was low, like 4 or less, answer would have been 17.2. Remember, I don't have to type in x equals, just the number. Sometimes I don't have to round anything, like on question number 33. I didn't have to round anything. But notice in number 34, I did have to. In real life case scenarios, you guys measure your height. You guys can measure your height. You guys can measure the height, your shadow. You guys can measure the shadow of a tree, a building, or whatever it is you're measuring. More than likely, your answer will have decimals in real life cases. So looking at here, question number 35, we have a picture. How tall is a tree? Round your answer to the nearest tenth if necessary. I see the measurements are in feet. So as a matter of fact, on the homework, if this was a homework, I will say in feet, how tall is the tree? So you know we're measuring in feet. So I have two triangles in there. I see, I'm going to use the measurement of the tree. I'm going to call it X because I don't know what it is. That's what I'm solving for. But I see the shadow is 25. And again, there's the dotted line, so I create a triangle. But at the same time, I see a light post that is 5 feet tall, 2 feet shadow. So for my triangle, where X is, right, where the tree is, the two measurements that I see are X and 25. So I'm going to make a fraction out of that. X over 25 equals. Now I see that X is the height, and the height of the light post is 5, so X goes with 5. The shadow of the tree is 25, and that goes with 2. So I'm just going to cross multiply. 2x equals 25 times 5. I know it's 125. So I get that x is equal to 62.5, right? I divided both sides by 2. So x equals 62.5. Round your answers. Right here I have again, round your answer to the nearest tenth if necessary. So one decimal place. I already have my answer in one decimal place. So my answer will be 62.5. Looking at number 36 here. I'm going to say that I'm going to create a triangle here. There's that person that is 5 feet tall, and it has a shadow of 12 feet. I'm solving for the height of the tree. So I see a person 5 feet tall that has a shadow of 12 feet. But then I see a tree, except my triangles are not measured to scale. I see the tree is X feet tall. I don't know the height. And I'm going to say the shadow of the tree is going to be 156. Again, 156. The reason why I come up with 156, I know I don't see 156 here, but I know the distance from the tree to the one person is 144. But then the shadow does continue 12 feet more, right? That's when the shadow of the tree and the shadow of the person overlap. So the whole shadow of the tree, I have to add those two measurements. That's why I said 156. Okay, so let's see. Yeah. Okay, that's fine. Now looking at my triangle where the x is, there's two values of x. I mean, there's two values on that triangle. I'm looking at the triangle that has x. And I'm going to make a triangle with those two values. So I'm going to say x over 156. Like I said, I was looking at the triangle that has x. And x is corresponding with 5 from the other triangle. 156 is corresponding with 12. I think I can simplify numbers. I don't want to multiply it, deal with big numbers. I'm going to simplify and simplify a little sideways. 156 and 12 sideways. Let me divide each by 12. All right, 12 divided by 12 is 1. 156 divided by 12 is 13. We don't have to simplify, right? We have use of a calculator. You can always cross multiply. Okay, here I have a question. It says, if I do get an answer of 10.08 and I round it up, would my answer be 10.1? Yes, because the 8 pushed the 0. So yeah. All right, now coming back to this question, let me cross multiply. 1 times x equals 13 times 5. That's 65. Yep, x equals 65. I got that on the chat as well. Good. X equals 65. Now you just have to cross, answer will be 65 and that's it. So part of your questions for today, for your homework, for your quiz, part of them are word problems. Notice how 33 and 34, they were completely word problems. I had to create my triangles. And then 35, 36, they're still word problems. And I still created triangles, but at least I started seeing a few of my figures in here. All right, so once again, this is part of your homework, part of your quiz, but not all of it. Now we're gonna move on. Let me flip to the next page. I'm gonna zoom out later so you guys can see them all. We're gonna start stating if triangles are similar. I know we talk about in the past, we talk about triangles being congruent, right? That was semester 1. We talk about congruent and you guys remembered side, 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 angle, side. Some rules that we learned when triangles were congruent. Now, congruent was the triangles have the same shape and same size. Now, similar, which is what we're working with now, triangles still have the same shape, but not quite the same size. And there's only 3 rules that we use. One of the rules, let me state that the rules appeared. One of the rules that we use is side, side, side. That one, if you guys remember from congruency, side, 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 I'm going to be using all 3 sides of the triangle. Another rule that we're going to be using is side, angle, side. Remember, we used to say 2 sides in the included angle. So the angle is not just any angle from the triangle, it's the angle made by the 2 sides. Notice how the angle is in between the sides. So side angle side is 2 sides and the angle made by the sides. I know in congruency, like I said, back in the days when triangles were congruent, one rule that did not work was angle, angle, angle. Angle, angle, angle was not a good rule for congruency because it could give me a small triangle, it could give me a big triangle with the same angles. So it was not the same size, but for similarity, angle, angle, angle works. But the way we call it is not angle, angle, angle. We just call it angle, angle. Technically, if 2 angles of one triangle are equal, the third angle it's equal as well. So 2 angles is enough. So we call it angle, angle. Those are the 3 rules that we're going to be using. If we're using angles, notice for angle, angle, or side, angle, side, if we're using angles, the angles must be identical, the same number. Again, we talked about it a few days ago that for similarity, angles have to be equal. So if I'm using angles, they have to be equal. If I'm using sides, they have to be proportional. We'll be dealing with proportion, so the sides have to be proportional. Let's take a look. Number 37. Nice thing that I see here is angle R is equal to angle L, right? They were marked already. So The cool thing is I already have two angles, one angle of each triangle. I know the rule that we learned last semester, vertical angle theorem. That should ring a bell. Vertical angle theorem. Vertical angle theorem states that when there's an x, when there's an x formed, opposite angles are equal. So I'm going to say that this angle on top, I'm going to do two arcs for that one. That angle is equal to this angle. I'm doing that based on the vertical angle theorem. When there's an x formed, opposite angles are equal. I don't know exactly how big they are. I just know they're equal. I see two angles of one triangle, right? One of my triangles, you guys can see, it's this one. Let me highlight. That's one triangle. And you guys can see the other triangle on the other side. I see two angles of one triangle are equal to two angles of the other triangle. So that's enough. I have angle, angle. So I'm going to complete this statement. Because here on the rules, it will say, state if the triangles in each pair are similar. So I am saying if they are similar, that doesn't mean that they are all similar. Some of them are, some of them are not. So if it is similar, so if I continue reading the instructions, it says, if so, so if they are similar, state how do you know they are similar and complete the similarity statement. I just said that I know they are similar, right? If they were not similar, I would just write not similar. I'll show you guys in a minute what happens when it's not similar. But this one is. So I'm going to complete the statement. Order matters. So I see here the statement starts with triangle QRS is similar to. We use the little thing, like you guys see it there. I'm going to highlight it. I'm going to rewrite this. That is the symbol for similar. So I see triangle QRS is similar to, and I complete the statement. So the way I'm going to type this, order matters. QRS, if you notice, is my triangle that I highlighted in yellow. Angle Q from the top goes with angle Q from the bottom. Angle R, notice how angle R has one slash. Angle R goes with angle L. And then angle S goes with angle M. Triangles have three angles, and the way we name the triangles by doing the three letters. One thing though, make sure they are capital letters. I have here on the chat, somebody said QML. It's actually QLM. Order matters, and make sure they are capitalized. If you use lowercase QLM, not gonna be correct. Has to be capitalized. And then I'm gonna put a space and I'm gonna write the word by, like BY. And then which rule did I use? Did I use side, side, side? Did I use side, angle, side? Did I use angle, angle? But I said earlier, I'm gonna use that rule, angle, angle. Thank you. I got on the chat, angle, angle. So that's my answer. I completed the statement, right? I'm stating how do I know that they're similar by angle, angle. Remember, we only have three rules: side, 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 angle, angle. One of them is good, so angle, angle. Order matters. Notice that most of my letters are capitalized. The only letters I don't have capitalized is by. Now I have a question on the chat. It says, do we put this full answer in our homework or just QLM? And then a person says, when typing in our homework, do we put QLM by angle, angle, or what do we put? We do put everything that I wrote here, QLM by angle, angle. Because remember, on the instruction, it said, if it is similar, complete the statement and state how you know. So by saying how you know is obviously which rule you're using. So yeah, the whole thing, QLM by angle, angle. Don't forget the spaces in between my words. Let me emphasize, there's a space here and there's a space here, okay? Let's take a look at another example. All right, so looking at number 38, if it is not similar, what do we put? I got that question in the chat. We'll see that in a minute. We'll see that in a minute, okay? So now here, I see sides, Okay, so I see that one of my triangles has the numbers 30 and 39. Okay, so I'm gonna make a fraction out of that. 30 over 39 equals, and I'm gonna compare my numbers with the numbers from the other triangle, right? 30 is smaller than 39, so I'm gonna say 30 goes with 80, and 39 goes with 104. Notice how the small number goes with the small numbered, the big number goes with the big numbered. Now, there's two ways how we can check if these two are proportional. One, simplify the fractions. Right, I see on the left, I will divide each by 3 and see if I can simplify. Another way we can do this, if simplifying fraction is not your thing, like I said, we can simplify, and that's how we check. They will be proportional if my fractions simplify to the same thing. Now, what if I don't like to simplify? Then I'm gonna cross multiply it. 30 times 104. 30 times 104 is 3,120. And this other way, 39 times 80. I'm using a calculator, and it gives me 3,120. I got the same number. My sides are proportional. Said I could have simplified, but I can also cross multiply. So my sides are proportional. So I have two sides. Unfortunately, my rules, I don't have side, right? Side is not enough. But there is one rule I just mentioned a few minutes ago. I'm gonna say this angle is equal to this angle. Vertical angle theorem. Every time there's an X form, opposite angles are equal. So I notice on one triangle, I have two sides in the included angle. Included angle is basically the angle made by the sides. On my other triangle, I have two sides in the included angle. I'm looking, when I said I have, is what is marked. What do I have information about? So I think side angle side, you guys can see, two sides included angle, side angle side. Thank you, Mercedes, thank you. All right, so it is similar. I'm gonna complete the statement. So EFG, so they're saying EFG. If you guys notice, EFG, that's from my red triangle. And I'm gonna say, all right, E from the red triangles goes with E from the blue triangle, right? E goes with E, I can tell. Now F, my question could be, is my answer will be EQR or will it be ERQ? Order matters, order matters. So here somebody says it is RQ. We'll see. Now I see that I have to do EF. And if I see the side EF, EF is the small side of my red triangle, right? Because there's 80 and 104. EF is the small side. So EF goes with my side EQ. Okay, so I think I can see already. So F is going to go with Q and G is going to go with R. So it is EQR. All right, I have two more people here that said EQR. Good job. EQR. So yeah, EFG is similar to UQR by, in this case, we used side angle side. Right? It is similar by side angle side, so we complete the statement. All right, let's take a look. What about question number 39? Now here, why is it EQR? Okay, I got a question here. Why is it EQR? Okay, so remember, we said E from the red triangle goes with E from the blue triangle. So, and when I see that here, it says EFG, right? The statement given is said EFG is similar to what? Now, F goes with Q. The reason why I know F goes with Q, because notice the side EF, notice how I highlighted the side EF? EF is the small side from the red triangle, right? EF, it is smaller than EG. So EF goes with EQ. Okay, now let's move on to question number 39. Here, I have all three sides of my triangle. Yeah. Let me try side, right? That's one of the rules. From the triangle on the top, as a matter of fact, let me call this my red triangle. I have three measurements. My measurements are 5, 6, and 8. So I'm going to use three fractions now. Okay, now I'm going to, because I'm using three fractions, I cannot put three numbers in a fraction, so I'm going to make three fractions. Now I'm going to keep this all on the top. From my blue triangle, the other triangle, I'm going to call it my blue triangle. My measurements are 20, 24, 32. Notice that in the red triangle or the blue triangle, my three numbers, I went from small to large. All right, so let's see. Let me simplify my fractions. I can cross multiply two fractions at a time to see if they're proportional, but the numbers are not that big. I think I'm going to try with simplifying. Actually, we can cross multiply two fractions at a time, but I'm going to simplify. 5 over 20, that simplifies to 1 over 4, right? Because I divided each number by 5. My second fraction, let me divide each number by 6, and that gives me 1 over 4. My last fraction, let me divide each number by 8, and that gives me 1 over 4. All right, the sides are proportional. Sides are proportional, so I'm going to use side. Now I have to complete my statement, right? I just said right now, side. So I just said how we're going to complete the statement. Now my answer, order matters, right? So STU, if you notice STU, that's the blue triangle. Here it says, I'm confused. How do you know? How do you determine what numbers go with what number? For example, 5 over 20, okay? Notice on my red numbers, 5, 6, 8. I wrote them from small to large. 5, 6, 8. I put them in order, numerical order. Notice on my blue numbers, 20, 24, and 32. I did the same from small to large. So when I'm using all three measurements, write them from small to large. So that's how you know what goes with what. And here it says, how do you know it's side? Because I'm using three sides. Remember, side, I'm using three sides. I am using the three sides of the triangle. So side. Now here I have to complete the statement. So STU, if you notice, S is away from the biggest side. So I'm going to say S goes with S from the other triangle. All right, so my first letter is S. Then I had to compare T because the statement started with STU. So my second letter is T. Notice how T is the opposite number is the smallest from all three. So I'm going to say that one goes with K. So T goes with K. So obviously it will be SKJ by side. Okay. Now here I have, what do you do when they're not similar? I'll get to you in a minute. We'll see in a minute. Okay. So let's take a look at number 40. I see three sides. Let me use three fractions again. I'm going to try to go for side. Looking on the triangle on the top, let me call it my red triangle. I'm using the three numbers, so I'm going to write 37, 40, and 52. Notice I wrote them from small to large. Now on the blue triangle, right, the triangle on the bottom, I'm going to write 9, 10, 13. Okay. I went from small to large. I'm going to simplify my fractions. The one in the middle is easy to simplify, right? 40 over 10, that's 4 over 1. Let's see, the last one, let me divide by 13. 52 divided by 13 is 4. 13 divided by 13 is 1. Now, 37 and 9, I cannot make it 4 over 1, right? I could divide by 9. It makes the bottom a 1, but the top is not 4 over 1. So I'm going to say, because of this one, they're not all proportional. I was not able to simplify one of my fractions to 4 over 1. I needed them, all of them, to be similar or proportional. Now, this fraction, these triangles are not similar. So when they're not similar, remember earlier it said, state if they are similar. If they are, state how do you know? This one is not similar, so I'm just going to type not similar. This one is not similar. Going back to the rules that we can use, let me highlight it with green so it stands out. The rules that we can use are side, 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 angle, side, or angle, angle. For side, 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 if you look at number 39, for side, 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 all sides have to be proportional. For side, angle, side, if you look at question number 38, side, angle, side, I'm using 2 sides and the included angle. For angle, angle, I'm only using 2 angles. You see number 37. Some cases, it is not similar. You guys see it in number 40. So on the notes, I gave you one of each. Your homework, you have 10 questions. So obviously, I'm going to give you more than one for each. Let me take roll really quick. Hold on, don't log out yet. Let me take a picture of this screen. Let's see. Now the work from today, it is a little intense. So here it says, so to put the answer MLK, would be just MLK not similar? No, we're not completing the statement. We're not completing the statement. So matter of fact, if we were writing this by hand, I will have you complete the whole statement. So like number 37, if we were writing, I would just say I will say QRS similar to QLM by angle, angle. If we were writing that by hand, but I'm just like, you know what? I'm just going to have you guys complete the statement. So just QLM by angle, angle. Now, when it is not similar, like number 40, not similar. We don't even start. We don't even care about MLK now because it is not similar. Now, see here, I got you here. Okay, so let me stop the recording.